Okay, this podcast is an introduction to acids and bases and their properties and what they are and how to name them. So first, we're going to talk about some of the properties of acids and bases. Acids have a sour taste. They're corrosive. That's why acid rain is a problem. They have a pH less than 7, and if you have blue litmus paper, they will turn it to red. Bases have a bitter taste, and they have a slippery feel to them. pH is higher than 7, and red litmus paper will be turned to blue by them. And here's a picture of the pH scale. So here are some examples of common household acids and bases. Lots of things in their house are acids and bases. Acids include lemon, or really any citrus, vinegar, aspirin is an acid, vitamin C, and battery acid in your car is a really, really strong acid. There's other ones too. Bases are shown in this picture on the right, and they include any soap is a base, bleach and ammonia are both bases, drain cleaner, and baking soda. So naming acids and bases, there's two basic categories for how to name them. And we're going to do this chart which includes both of them. The first one is polyatomic acids, acids made from the polyatomic ions, anions that we've already learned. And for these, you change the ending to ic and add the word acid. And then the halogen acids, where you put hydro at the beginning of the name, and then the halogen name, and then ic, and then acid. And I'll show you some examples of these. So we're going to complete this chart in columns. So we'll do the first column first, which is the formula for the anions. And any of these that you don't know of the polyatomic anions, you can find them on your anion sheet, so you don't have to memorize them. And then we'll do each column one at a time. So here we get the anions from the anion sheet, and that includes sulfate and nitrate, acetate, phosphate, and then we have the halogens, which are chloride and bromide and iodide and fluoride. So then we look at the anion to figure out how many protons, how many H pluses we're going to have in our acid. So if it is a -2, it means that we're going to need 2 protons. If it's a -1, like nitrate, we're going to need 1 proton. So we'll fill in that table next. Okay, so most of them are -1, but notice like phosphate has a -3, so we're going to need 3 protons. Halogens are all -1. So that leads us to what type of acid. If it's 1 proton, we call it monoprotic. If it has 2 protons, we call it diprotic. And then triprotic means it would have 3. So following the next column, we'll fill this in. So again, notice that because sulfate had 2 protons, it is diprotic, and then phosphate has 3 protons, it is triprotic. So that leads us to the formula of the acid, and just like polyatomic ions, the cations went first, and in this case, the protons are going to go first in the formula. So I'll do the first one together. So sulfate is going to have 2 protons, and they're going to go at the beginning of the formula. So we'll fill that chart in. Okay, so actually, if a formula starts with an H, that's a symbol, that's a signal that it is an acid. So that's why the hydrogen always goes at the beginning, because it tells everyone that this is an acid formula. All of the H pluses go at the beginning. So notice that acetate has other protons in it, but they're not acidic protons. it has other hydrogens, but they're not H pluses, so they go in the middle, and the H plus is the one that goes at the beginning. So these are all the formulas of the acid, and now we're going to do the name. And again, the names are going to follow the rules that we have up here. So here are the names of the acids, and I'll go through these. So sulfate becomes sulfuric acid. Again, the ending is changed to ic, and then we add acid. Nitrate, we drop off the 8, and it becomes nitric acid. Acetate becomes acetic or acetic acid. Phosphate becomes phosphoric acid. We add the OR in there to make it easier to say. And then the rest of them are the halogen acids. So chloride becomes hydrochloric acid. And then the same pattern, we see bromide, hydrobromic acid. Iodide, hydroiodic acid, and fluoride is hydrofluoric acid. Same pattern all the way through. So naming bases, we've actually already named bases because the only bases that we name with rules are the hydroxide compounds, which we've already done when we did ionic compounds. So this is just a review for that. So here, sodium hydroxide has a sodium, which is +1, and then a hydroxide, which is -1. So just to recall that hydroxide ion has an OH with a -1 charge. So this is always hydroxide. So sodium hydroxide is NaOH, and then magnesium hydroxide, aluminum hydroxide is, aluminum has a +3, so we need 3 hydroxides, and then LiOH is lithium hydroxide. Exactly the same way that we named them previously. Okay, the pH scale is the strength of an acid or base depends on how many protons it has, and protons, remember, are H pluses. That's a hydrogen with a plus charge. A P scale is a log base scale, and what that means is that between each number there's a 10-fold jump. So for example, when you go from pH 4 to pH 5, it's from pH 5 to pH 4 is 10 times more acidic because it's a 1-number jump. And from pH 10 to pH 8, pH 10 is 100 times more basic because it's 2-number jump. So for every number, it's times 10. So if it was a 3-number jump, it would be times 1,000, 10 times 10 times 10. And most pH ranges go from 0 to 14. There are some cases for really strong acids that have a pH below 0, but that isn't very common. So this is a summary of the pH scale. If it is a neutral solution, the pH is going to be exactly 7. If it's acidic, it is below 7, and if it's basic, it's going to be above 7. So how far it is above and below 7 will determine how strong the acid or the base is.